Okay, now we have all the three data sets into R, and we might want to take a look at the layout of these experiments. In this video, I'll show you how to use ggplot function to display the layout. So remember, we have loaded the package ggplot2, and then we'll use the ggplot function, ggplot, and we need to first specify the data set we want to plot, which is data 1. Let's first do that for data 1. And then, since we want to see the layout of this experiment, so we'll set the x-axis to be the row variable and the y-axis to be the column variable. So AS function, and we let x equal to p row and y equal to prng, which is the row column variable, and we'll use plus geom point, which will give you a scatter plot for the row and the column coordinates. And let's make the point size to be 2, so size equal to 2. So let's see what we get. Okay. So you can see here is how the layout of experiment looks like. And if you want to see like the different trial in different color, you can simply add color here equal to the trial variable, which for this data set, the trial variable is called block BLOC. But please note that instead of just simply put block here, we need to transform the block variable into a factor, because the original block variable is a numerical variable. So let's see what we get now. We can see this, the first trial, second trial, third and fourth, and they're in different colors. Okay. And in addition, we can also make a plot for different sub-experiments. Okay. So again, we have x equal to p row, y equal to prng, and color equal to the sub-experiment variable, which is called expd. Okay. So here, since the experiment variable is already a categorical variable, is already a factor, so we don't have to transform it into a factor again. So we just put expd there, and then we use a geom point size equal to, again, equal to 2. Okay, you can see here's what we get, and this is the legend of this plot, the names of these sub-experiments and their corresponding colors. And next, let's make a plot for data 2. Okay. So similar to the first data set, we put data 2 here, and again, the row variable x equal to, let's see, x equal to, I think, row, and y equal to column. And then let's again make a plot for different trials. Okay. So then color equal to factor trial. Okay. plus jump point so equal to 2. Okay. So here's the plot for data 2. Okay. So we have 9 trials. Okay, the last data set, data 3, ggplot data 3, and now x equal to row, y equal to col, and here let's make a plot with the different blocks in different color, because you can see here we have 12 blocks for this data set. So we make color equal to block. And again, since block is already a factor, so we don't have to transform it into a factor again. Then we again plus the jump point. And here's the plot of the layout of the last experiment. Okay. And this is how we use ggplot to plot the layout of the experiments. And the last thing we want to do is to see if there's any noticeable outliers for the data sets. And if there are, we need to remove them. So we simply look at the box plot of the yield variable. Okay. So we just use the box plot function. Okay. And for data set 1, the yield variable is called BUAC5. And let's make the name of y-axis as yield. Okay. Let's see what the box plot looks like. So as you can see, there is some very small values here and even a very large negative value. Okay. So here, let's just remove all yield values that are less than 30, and we only keep the ones that are greater than 30. So how do we do that? We'll use the filter function in the dplyr package here. Okay. So there are 2 ways of doing this. So let's first give a new name for this data set. Let's call it data 1.1. And the field function. So the first way to do this is put the data set, the name of the data set here as the first argument. That means we'll apply the filter function on this data set. And then we specify the subset of rows. So here we want to only keep the yield values that are greater than or equal to 30. Okay? So we'll just simply put BUAC5 greater than or equal to 30. So this data 1.1 here, you can see some of the observations were removed after we using the filter function. So this new data set does not contain any observations that has a yield less than 30. Okay? And the second way of doing this is similar, but we just use a new sign. Okay? So we, instead of put field function here, we put data 1 here, and we use this new sign, this dollar greater than dollar sign. And then we add filter function here. So that means this filter function, this sign means that this filter function is applied to this data set. And then for the filter function here, we don't have to put data 1 here again. Instead, we just put the subset of the rows. Okay, so it's like 5 greater than or equal to 30. That's it, and we'll get the same thing. So it's view at 5. And next, let's make the box plot for data 2 and data 3. Okay. So box plot of data 2. The yield is called GYTHA. And this is a box for data 2. And since they are not very large outliers, so we just keep them there without make any changes. And box plot for data 3, the yield. Also, we have this one, which is a bit larger than others, but this is not a noticeable outlier. So again, we won't make any changes to this dataset. And this is how we do some simple detection for outliers and how to remove the outliers before we feed the model. And next, I'll show you how to fit a model for each of these 3 datasets in next 3 videos.